Welcome to the first tutorial video on the topic indices. So my name is Abraham Ofori, and in this video I'll take you through the introduction of indices and some rules governing indices. So let's start. So definition: an index, a to the power n, or power, is used to show that a quantity is repeatedly multiplied by itself n times. So here, where n is the index or the power and a is called the base, and n is also um, part of the real numbers. Okay, so n belongs to the real numbers. So if I have a to the power n, I'm saying that this shows that a is being multiplied by itself n times. Okay, so examples are, if I have a to the power 4, it means a is multiplied by itself how many times? 4 times. It's 1, 2, 3, 4. This can be rewritten as what? A to the power 4. So I have 3 to the power 3 is the same as 3 times 3 times 3. And so 4 times 4 times 4 times 4 times 4. How many? 1, 2, 3, 4, 5. Can be rewritten as what? 4 to the power 5. So that's the introduction or the definition for indices. Okay. So what if you have something like this? 2 to the power 0. What happens? Okay. Does this mean you are multiplying 2 by itself 0 times? Or if you have 2 to the power negative 3, it means I'm multiplying 2 by itself negative 3 times. Or what? Or if I have 2 to the power 1 over 3, it means I'm multiplying 2 by itself 1/3 times, or what? So this happens, and then how do we express these in this? Okay, we then learn some rules to help us on such expression. So before you can know all these, you have to learn some rules. Okay, so let's start. So if you have something like this, you are going through the rules of indices. If I have a to the power 3 times a to the power 2, okay, how did we express a to the power 3 in our first video? In our first example that we did. So I can express a to the power 3 as what? A times 3, sorry, a times a times a. That is 3 times. Then times, this is the times. A to the power 2 is what? A times 2. Now, if you want to write all these as 1 a to the power something, how do we do it? We count them. So 1, 2, 3, 4, 5. So I can take one of these a's and I write all of it as what? A to the power 5. Pretty cool, right? But if you look at it clearly, this 5 is the same as summing the powers here. Okay, so what happens? Then this takes us to the first rule of indices, which states that if you have two index multiplying or two numbers in their indices form multiplying and the bases are the same, look at it clearly, the bases should be what? The same, a. Then we can take one of the base and add the powers. This is true because we can prove it using this. Okay, all right. So let's see an example on that. We have 2 to the power 5 times 2 to the power 7. This can be written as 2 to the power 5 plus 7. And this 2 to the power 12, which in expressing it or simplifying it will get 4096. But if you have something like this, 2 to the power 5 times 3 to the power 7, I can't add these because they are of different bases. Okay, now I can simply simplify this, which is 32, and simplify this one, which is this, and multiply like this. So I'm just showing it that if the bases are not the same, there's no way you can add the powers. Okay, just put that in mind. Okay, and the bases too, they can be m, they can be of base y. Like that is why how mathematics is like. Once you know this, you have to make sure that anywhere you meet it, you can solve it. If they change the base from a to 2, you have to be able to understand or be able to solve it. If they change the base to, let's say, q, you're supposed to get the question right. Okay, like I said, because they have different bases, you can't add this one. What if, okay, you have something like this, a to the power 3 over a to the power 2. A to the power 3 is what? Just rewriting as this. And a to the power 2 is this. Okay. Now, if I have this in common division, I can, this a can take this a out. So this a can cancel this a. This a2 can cancel this a. And I'll be left with what? A. So this a will go into this a1. So it becomes 1 here. and 1 here. This a will go into this a 1 1, so it becomes 1 times 1, which will be 1, 1 times 1, which will be 1. In the end, it becomes a times 1 over 1, which is a. But look at this a clearly. This a is simply the same as subtracting this 3, this 2 from this 3. Okay, do you see that? If I subtract 2 from this 3, I'll get what? 1, a to the power, which is a. Any number to the power 1, you just write the number. You don't write the power, okay? So then this takes us to some interesting rule that states that is a quotient that states that if you have the same basis dividing, then I can take one of the base, then I subtract the powers. That is how it is, okay? So this is very simple. You can do it by hand. It's not a rule that someone stated. You can use it, just use this one and prove it, okay? Alright, so examples are this. If I have 2 to the power 7 over 2 to the power 5, it's the same as 2 to the power 7 minus 5, which is 2 to the power 4, and that will give me 4. Sorry, 2 to the power 2, and that will give me 4. Okay. So what about the third rule? The third rule for this, if I have a to the power 1 over n, then this is a rule saying that it's the same as the nth root of a. But if I have a special case where a to the power half is the same as square root of a, we've done a video on said, and you understand this if you watch that video. For example, is a to the power 4, sorry, 2 to the power 1 over 4 is the same as the fourth root of a, and 3 to the power half is the same as the square root of 3. Now we have some other properties, so you should know that we have only 3 rules in indices, but we have some other properties that are generated from the rules. Look at this. The quotient rule is saying that if I have a to the power m over a to the power m, then I can subtract them, right? Okay. If I have a to the power m over a to the power m, what does this tell us? It means I have the same number here divided by the same number. And any number divided by itself is what? 1. Like 2 over 2 is 1. 3 over 3 is 1. 2 to the power 5 is 32 over 2 to the power 5, which is 32. 32 over 32 is what? 1. But this can be rewritten as what? A to the power m minus m. And m minus m is what? 0. If I have 1 minus 1, I get 0. 2 minus 2, I get 0. So this one is actually equal to what? A to the power 0. So this takes us to a very interesting property or something like that. If I express this in numbers, and this is how it is. You can point 8 over 8 in calculator on a calculator and you get 1. So this takes us to an interesting property saying that any number to the power 0 is what? 1. And it's not just by magic. It's from this simple rules that we studied from indices. Okay. So examples are 200 to the power 0 is 1. Z to the power 0 is what? 1. We have other properties as well. Okay, if I have this 2 to the power 2 all to the power 3. Now think of this as what? 2 to the power 2 being, let's say, a all to the power 3. What do? We said the number here raising to the power this is the same as saying that this number times itself this number of times. This is what I mean. If I have 2 square, it means all to the power, it means 2 square multiplying itself how many times? 3 times. It becomes 2 squared times 2 squared times 2 squared. Now this 2 squared can be simplified as well. 2 times 2. This one can be simplified as this. This can be simplified as, so they're all being multiplied. And from the multiplication rule, this is what we say. We say that we can count them 1, 2, 3, 4, 5, 6, and write it as what? 2 to the power 6 of them. And if you can see this clearly, then this is the same as what? Multiplying these powers. So simply, if I had known, or had I known that this was the same as this, I'll just write it straight like that. That I multiply this and this, I'll get 2 to the power 6. Very cool, right? So this, it takes us to another property that states that if I have, this is the power law. Okay, if I have an index raising to another power, okay, then I can multiply the two powers and take the base, so it becomes a to the power m times n. So the same thing like here. So all these properties that we are saying, whenever I meet them, try to figure them out. Don't just say it like that and say that I don't understand it. No, try to understand them, and wherever you meet them, you really know how to do the question or solve the question. For example, is if I have a to the power 4 or to the power 3, this is the same as a to the power 4 times 3, which will give me 12. Okay, if I have this is the same thing as that. What if I have something like this? Okay, 1 over a to the power n. What is this? What is 1? 1 is what? Any number to the power 0. So in terms of a, I can rewrite 1 as a to the power 0. Okay. Now, if I have the quotient rule, it states that what? If I have the same basis and they are dividing, I can take what? One of the base and subtract the powers. So it becomes 0 minus n. And 0 minus any number is what? Negative of that number. So it becomes a to the negative n. But this means that if I have a to the power negative n, is the same as 1 over a to the power positive n. Very cool, right? This property is like that. A to the power negative n is the same as 1 over a to the power positive n. So in other words, it's the same as 1 over negative of whatever that is here. And negative times negative will give me what? Positive. So if I have a to the power n, I can rewrite this as what? 1 over negative of what is here. And that becomes what? Negative of that. You can even go through this using this. That this is the same as a to the power 0. And this becomes a to the power 0 minus negative n. Sorry, this becomes a to the power 0, okay? And I can write this as what? A to the power 0 minus negative n. And negative will give me positive. That will give me a to the power n. Okay? Pretty cool, right? Example is this. If I have 2 to the power negative 2 is the same as 1 over 2 squared. And this becomes 1 over 4. If I have 1 over 7 to the power negative 2 is the same as what? 7 to the power 2. This is it. If I have this, I can take this back to this one. 1 over 2 to the power 2 is the same as 2 to the power negative of that. So if I have 1 over 7 to the power negative 2 is the same as 7 to the power negative of whatever that is here. And negative of negative 2 is what? 2. And this becomes 49. So I have this. If I have this, okay, let's look at something. If I have this, I can expand this top, the power here, the fraction, and write 1 over 4 times 3. This will give me the same as this. Okay, but from the power rule that we learned, this one, we said if I have this, or if I have this one, a to the power m times n, I can write this as what? A to the power m or to the power the last one, or you can even interchange them, and it works. Okay, so if I have this multiplying and a to the power of the whole of this, then I can take one of them, simplify with a to the power that or that, that's one that we took, and all to the power the last one. Okay, the same thing applies. What is a to the power 1 over 4? Is what? The fourth root of a, and then after that I cube it. So like I even stated it here that, mind you, if I have this, I can write this as this. Now if I have a to the power m over n, something like this, and they can be what? The nth root of a all to the power m. And or you can rewrite it as what? The nth root of a to the power m. This is when you first bring the 3 here. You maintain the 3 here and then all to the power 1 over 4. You can do it like that. You can even just write a to the power 3. Once this product or multiplication, you can do it like that. You can go through this and prove it. Okay, but you get the same thing. So example is this. If I have 16 to the power 3 over 4, then this is the same as what? The fourth root of 16 all cube. Fourth root of 16 is what? 2. And 2 cube will give me what? 8. So this is very, very simple. Thank you, and please subscribe to my YouTube channel for more videos. And like I said, if you follow our videos, you really understand that the mathematics that we are doing is not just chewing them. They're actually understandable. You can understand it going through them step by step. Okay, so know some formulas, know some identities, and know why a to the power 0 is 1. Know why a to the power negative 1 is negative 1 is the same as 1 over a to the power n. Know all these things, and then you start appreciating mathematics. Thank you once again, and don't forget to subscribe to my YouTube channel.